Hello. Today, our presentation introduces the toxic legacy of the more than 3,800 Second World War shipwrecks located throughout the Asia-Pacific region and what has been done to counter this threat. This presentation is based on work that has been undertaken by myself, Dr. Matt Carter, at the Major Projects Foundation, in collaboration with marine scientist Freya Goodsir from the UK Centre for Environment, Fisheries and Aquaculture Science. At this point, I'd like to acknowledge the partnership between the Major Projects Foundation and the Secretariat of the Pacific Regional Environmental Programme, SPREP, also our partnership with the Ocean Foundation, and the potential this represents for mitigating the threat that potentially polluting shipwrecks pose to the marine ecosystems, cultures and livelihoods of the Pacific. I'll now hand over to Freya for the first part of our presentation.
Thank you, Matt. There is a hidden legacy of World War shipwrecks at the bottom of our oceans. Numerous World War shipwrecks provide a rich maritime heritage, acting as artificial reefs supporting a range of marine life assisting to increase biological productivity. It is estimated that more than 3,800 shipwrecks lie within the Greater Pacific region. These shipwrecks contain cargoes such as war materials, chemicals, and oil. A portion of these cargoes could have been released during the time of their loss and/or released over time through sporadic releases. However, some shipwrecks have the potential to contain thousands of tons of pollutants such as oil. World War II shipwrecks have been submerged for more than 75 years and are therefore approaching structural collapse, hastened by severe weather events associated with climate change. Over time, a proportion of these wrecks are likely to be leaking oil or are likely to leak in the near future. Therefore, these potentially polluting shipwrecks pose a threat to the marine environment and the people who use it. Oil spills cause a wide range of impacts in the marine environment, with short and long-term effects. The severity of impact will depend on the type and quantity of oil exposed to, and the sensitivity of the marine receptor. Oil types present within shipwrecks vary from heavy persistent oils to lighter non-persistent oils. Many of the volatile elements which make up oil are broken down in the environment during a leaking event. Many of the heavier components settle on the seafloor and become incorporated within sediment. During larger spills, oil has the potential to be transported and spread to the shorelines dependent on the prevailing weather conditions in the area. Oil releases of this magnitude can cause serious impacts to the wider marine ecosystem. High-profile incidents demonstrate the devastating effects of an oil spill. This has been seen firsthand with the MV Wakashio, which spilled 1,000 tons of oil, triggering a state of emergency in July, and the MV Solomon Trader, which spilled 80 tons of heavy fuel oil in the Solomon Islands. The oil contained within these shipwrecks can not only cause significant environmental impacts, but can also cause high cleanup costs. So what can be done? As mentioned in a previous slide, there are a large number of shipwrecks in Pacific waters. However, it is not feasible to assess, evaluate and manage all of these shipwrecks. So prioritization is required to identify those shipwrecks which pose the highest risk to the marine environment. Information relating to the circumstances of the loss of the vessel and the potential damage sustained during the event can help inform the quantity of remaining oil on board. Some shipwrecks may have lost a proportion of oil during the time of the sinking through explosions, fires and damage to the tanks holding oil. Therefore, those shipwrecks with the highest pollution potential can be prioritized for further investigation. Shipwrecks which pose a significant pollution risk can be evaluated to assess the risk of probability of exposure to marine receptors through numerical modelling and evaluation. In the absence of information on the current condition of a shipwreck and the amount of tanks which may contain oil, baseline condition assessments can be used to determine the quantity of oil remaining on board. These surveys can inform the current state of the shipwreck and the potential changes to structural integrity over time. On-site environmental surveys can be used to determine both historical and active leaks. These surveys are designed to evaluate the health of the surrounding marine ecosystem and the impact of a potentially polluting wreck. Analytical analysis can be used to determine the presence and absence of oil-derived contamination, and fingerprinting can be used to determine the source of oil. Depending on the perceived level of risk, mitigation measures can range from doing nothing, initiating monitoring programs, to removing the remaining oil. While national authorities throughout the Pacific recognise the potential pollution risk posed by these shipwrecks, they are challenged with a lack of resource to address and manage potentially polluting wrecks within their waters. The scale of this challenge is such that it can only be addressed through multilateral partnership and strategic action. I would now like to hand back over to Matt to discuss the progress that has been made so far towards this goal.
From our research, we've identified Chuuk Lagoon in the Federated States of Micronesia as the largest concentration of potentially polluting shipwrecks in the Pacific. Chuuk, formerly known as Truk, was the main base of the Japanese Imperial Navy in the Pacific during the Second World War. During the war, around 65 ships were sunk within the lagoon, and to date 17 of these are thought to be pollution threats. In June 2019, I travelled to Chuuk to assist at a UNESCO field school aimed at building capacity amongst heritage officials throughout Micronesia in the essentials of marine archaeology. Importantly, this provided the opportunity to meet with various officials and discuss the threats posed by potentially polluting wrecks within their lagoon. We also began an initial assessment of the potentially polluting wrecks in Chuuk, and today I want to focus on one wreck in particular, that of the Rio de Janeiro Maru. This ship was launched in 1929 and during the Second World War served as a submarine tender for the Imperial Japanese Navy before being sunk in Chuuk Lagoon in 1944 by US aircraft. In order to assess the pollution potential of the wreck, we undertook a non-disturbance photographic and video survey. This survey was undertaken over 4 days and revealed that the vessel was lying on its starboard side in 12 to 35 metres of water. And in contrast to historical sources that stated it had broken in two amidship, it was intact from bow to stern. As you can see here, one of the outcomes of this survey was a 3D model of the wreck generated from 7,350 high-resolution images. This was the first shipwreck in Chuuk to be recorded in this way, and the model has proven to be a great asset, not only for assessing the condition of the wreck, but also communicating the size and scale of the threat it presents. From this baseline survey, we were able to evaluate the integrity of the Rio de Janeiro Maru's hull, which was used to complete a likelihood of oil release assessment. Following the methods established by Freya and her team at CFAS, this assessment analyses key criteria such as depth, history of leaks, hull integrity, and the length of time the vessel has been submerged to calculate how likely the wreck is to release oil in the future. Significantly, this standardised approach is also used by the British Ministry of Defence and has also been applied to several wrecks in Australia. Now, as such, the high risk of oil release score that the Rio de Janeiro Maru attained can be compared against the hundreds of vessels the MOD has already assessed, and in this way the threat it presents can be quantitatively ranked against those other wrecks. Now, evidently, the fact that the Rio de Janeiro Maru is believed to have a high likelihood of releasing oil in the future is a considerable environmental concern. The wreck itself is located adjacent to areas of mangroves, which are particularly vulnerable to the impacts of oil spills. And at a broader level, the Rio de Janeiro Maru and the other potentially polluting wrecks in the lagoon present a significant threat to the livelihoods of the Chuukese, many of whom rely on locally caught fish for subsistence and income. It's also worth mentioning that before COVID, dive tourism was one of the largest earners of foreign income for the country. Okay, so what has been done to mitigate this threat? Well, following the results of the Non-Disturbance survey and the likelihood of oil release assessment, we've reached out to the FSM Office of National Archives, Culture and Historic Preservation, the Department of Environment, Climate Change and Emergency Management, and the Chuuk Historic Preservation Office to partner together to mitigate the threat of potentially polluting wrecks in Chuuk Lagoon. This proposed work will be focused on building capacity within Micronesia to enable these authorities to effectively manage their potentially polluting wrecks. This will be achieved firstly through working with divers from Chuuk HPO and the Department of Marine Resources to survey the various potentially polluting wrecks to gather the required baseline data. This will then form the basis for individual wreck management plans that will assess the preservation issues facing the wrecks and the environmental threat they pose. Building on from this, a disaster risk reduction strategy will be written with FSM authorities to increase their ability to prepare for and respond to the predicted oil spills from these wrecks. And finally, if required, individual remediation action plans will be jointly written to provide a pathway through which the threat of marine pollution from the wrecks can be removed almost entirely. It is this collaborative model that we see as being most effective in creating the positive change required in the Pacific for the effective management of potentially polluting shipwrecks. This threat is too serious to be addressed without local engagement and too complex to overcome without international support. While our mission is currently most developed through our work in Chuuk, along with SPREP and the Ocean Foundation, we're embarking on similar projects with partners in the Historic Preservation Office and local council in the Marshall Islands in regards to the potentially polluting wrecks in Bikini Atoll, and are currently reaching out to authorities and stakeholders in the Solomon Islands. In closing, I want to recognise that potentially polluting shipwrecks throughout the Asia-Pacific region mean different things to different people. To some, they are cultural heritage sites and war graves. To others, artificial reefs and important fishing grounds. What is clear from our research to date is that it is only through genuine collaboration that we can protect the natural and cultural values of these wrecks and preserve these ecosystems for future generations. I'd just like to thank you all for listening to our presentation today. If you're interested to find out more, please look out for our forthcoming paper in early 2021, and I can be contacted on the email address here. Thank you.